Hi everyone, my name's Egfer, and today I'm going to be looking at these big old skyscrapers behind me. They don't need to be skyscrapers, you could build them into the ground if you wanted, but these are all about ways of doing downwards transmission with redstone. It's something that we often hear is quite difficult to do. Well, there's actually lots and lots of ways to do it. I'll be showing you some of those today. Some will be pretty obvious and familiar, and hopefully there'll be some which are quite new to you, including one which is completely wireless and could go from the top of the world down to the bottom of the world with no extra delay. So let's have a look at them. So before we get started, I should probably warn you, this is my first ever Minecraft video. It's actually my first ever YouTube video. So if it's complete pants, I'm really sorry. You just got to forgive me. Anyway, let's have a look at these first four. These ones in the yellow box are pretty simple circuits which use dust, repeaters, torches, that kind of thing. So you're probably fairly familiar with some of those anyway. The next two are water-based, including one down here, which is a bit silly and uses a boat. Observers, so an observer-based one. And the next three are piston-based, including a couple there using lots of slime blocks and honey blocks. Then this is what I was talking about earlier with the wireless transmission, uses daylight detectors. And finally over here, I've got one which is using items. It's not a great one. It's one that we can take a look at, and maybe actually you guys will have some good suggestions for how to make it even better. One thing to point out is all of these have got a dropper and a chest attached to them, top and bottom, and I'm going to be using that for some testing later. So that's not actually part of a circuit, but it will be used for testing. So you can see they've all got one. So that's today's video. It's about redstone vertical transmission. Okay, so let's dive straight in. So this is what got me thinking about downwards transmission in the first place. This control panel, the idea is I want to build an underground factory, and the control panel is going to be it's going to allow me to turn things on and off in that factory. Okay, so I've got a few different levers here, and each of them will operate different things within my factory. So I sort of quickly talk about some of the things which might be important for a downward circuit. Depending on what you're trying to achieve, different things will be important to you. For me, statefulness is important. I want to know that if my lever says that my factory is on, that my factory is on. It hasn't missed an update and actually turned everything off. So statefulness. I want it to look nice. I want it to be easy to reach. So I'd like it to be one wide and tileable. I'd like to have a small footprint, it doesn't stretch off into the distance, making it hard to work out where to start building in order to reach the right place down below. And you might want it to be fast. So how quickly does the circuit respond when you flick the lever at the top? And that could be a few ticks, it could be quite a lot of ticks. Easy to build, and some are easy to build upwards, some are easy to build downwards. We'll have a look at that. Accurate. So this is about how well what I do at the top is reflected at the bottom. So imagine I've got a dropper connected to the bottom of my circuit, and I flick a lever 10 times. Does the dropper at the bottom spit out 10 items? And if it does, that's accurate. And I might want it cheap as well. So, you know, some things use some fairly expensive late game type resources. There's others I'll show you which are extremely cheap to build. Okay, so let's look at these in more detail. We'll start off over here. So this is a simple redstone staircase. I'm pretty sure that everybody, day 2 of Minecraft, there you were digging down to your mine, hoping to find some diamonds. Maybe it wasn't day 2 for you, maybe day 2 you were busy picking flowers or cowering in your dirt hut, I don't know. But, you know, I'm not judging, right? So, put some redstone on that staircase and you got yourself a downwards transmission circuit. The only thing you need to do is every 15 redstone steps, you need to put in a repeater, and that will carry on the signal going down, otherwise it runs out of juice. pretty simple. And you can more or less tile it. It is one wide. It's also pretty fast, right? And it's cheap. It's got a lot going for it, really. The only problem is it's got quite a big footprint. So, it goes along quite a long way. So if you want to make that a bit tidier, this might be your next best bet. And this is the spiral staircase. And again, we've probably all, in our survival worlds, gone down a spiral staircase thinking, I'm not going to mine straight down because I'll end up in a lava pit. So you built one of these, carefully gone down. The only thing here is you have to count pretty carefully to make sure that on your 15th step, you stop, you put a torch in, then you drop down, and you can carry on your spiral staircase. It's kind of great. Of course, it means it's not very good as a staircase because you can't climb back up it, but that's not what we're about right now. We're doing downwards transmission of redstone, so this would work. And so then if I turn it on, you can see that's pretty fast down there. It's only got a couple of torches, so it's a 2-tick delay in reality. I've had to put a torch at the bottom because there's a torch halfway up, and that inverts the signal. So if I didn't have this torch down here, I'd be getting power when this was off at the top. So you always need an even number of torches to get the right signal at the bottom. So that is your spiral redstone staircase. It's 2x2 and it's not really tileable, so that's the problem with that one. So let's get on to the first one, which is properly tileable, one wide, and has a small footprint as well. So what I'm doing here is I am powering this block here. That powers the repeater, which hard powers this block. Because it's hard powered, it can send the signal down to this redstone dust, which soft powers this block, but a repeater can pull soft power out. It hard powers this block, powers the redstone dust, etc., all the way down. And on the other side, it's exactly the same, but the other way around. So I've got my repeaters facing the other way, and my redstone dust is alternating on opposite sides. And I can keep going out as wide as I want doing that. You'll notice this one is quite a lot slower than the first two, and that's because every 2 levels you've got a repeater, and each repeater takes 1 tick of delay. The next one along is a torch cascade. So you might recognize this torch above some redstone. Does that look a lot like this? Yes, it does. But I'm doing that all the way down now. So torch, redstone, torch, redstone, torch, redstone. And you can see this left-hand side is all lit and the right-hand side is all turned off. And when I press the lever, it swaps around. So the right-hand side is all lit and the left-hand side is all turned off. This is also a bit slow for exactly the same reason as the last one. Each torch adds a tick of delay, and I've got a lot of torches every 2 steps. So they're pretty much the same speed. This one is probably a bit more expensive because it uses repeaters rather than torches. Neither's particularly easy to build underground, frankly, but there you go. So those are my 4 simple systems which use basically dust, repeaters, and torches. Right, so water-based systems. These two use water to transmit a signal downwards, and the way they do that essentially is with a dispenser with water in it, a hole in the ground, or a tower that you've built up, and an observer at the bottom which detects when there's water in front of it or not. So what I'll show you is I can pull this lever here. The dispenser drops water down this column, gets to the bottom. The observer sees it and he lights up, pulses this lamp. Oops, stuck. Okay, so when I turn it off again, the dispenser sucks up the water, same thing happens, down it goes, observer spots it, pulses the lamp. And what you'll notice pretty much straight away about this system is it's different to the ones we've seen before because it's using an observer at the bottom and it's emitting a pulse. It's not stateful. Okay, so observers don't care about on or off, they just care about change. So if they see something go from on to off or off to on, to them it's the same thing. They'll just emit a pulse from the bottom. And that doesn't really help me to know what state my underground factory is in. What I can do is I can use a T flip-flop down here. And if you don't know what that is, that's a toggleable flip-flop. And what it does is it converts a pulse into an off signal or an on signal in turn. So the first pulse will maybe turn something on, the next pulse will turn it off again. So that's what the toggleable flip-flop does. But for that to work, I've got to know I get the right number of pulses at the bottom so that when this is off, I've always had enough pulses for my T flip-flop to turn off, and when it's on, I've had enough pulses for my T flip-flop to turn on. Without wanting to be a spoil sport, I can tell you that that is very hard to achieve. So whilst it's a pretty cheap way of getting a signal to go a long way, because water doesn't really cost you anything, for my particular users, it's not that great. However, I can turn a water-based system into a stateful one, like this. Same idea, a slightly bigger column of water, 2 dispensers, and now I've got a boat and a pressure plate. And when there's water in the column, the boat floats up, comes off the pressure plate, the light turns off, suck the water back into the dispensers, the boat falls down, and the light lights up. And well, if you want to be a bit more exciting and adventurous about this doesn't have to be a boat. It could be a Ravager. Works in just the same way. It might be a bit more exciting. I'm not sure you'd use this for anything apart from a fun novelty anyway. So, you've got a choice between a boat and a Ravager. Well, why not the Ravager? So those are my 2 water-based systems. Next, we come to an observer tower. So this is the first one we've looked at, which is actually 1 by 1. So it's very, very space efficient. And let's just do a quick demo first. Flick the switch, and it sends a pulse down to the bottom. So what's actually happening is this lever is powering the lamp. All of these observers are facing directly upwards. So this one sees the lamp turn on, and it sends a little signal down, and each of the observers in turn sends a signal to the next, all the way down the chain. This final one powers a block, which pulses this lamp here. So it's really, really simple, very, very straightforward, easy to build. But again, this one is, because it's using observers, is stateless, and I would need a T flip-flop of some sort to be able to get it to toggle on and off when I need it to. So there's not a lot to say about that. It's a bit slow, but it is very, very space efficient. But it does need a T flip-flop to make it stateful. Okay, so here are my piston-based ones, and I'm going to start off over here. Let me just turn it off actually. Here I've got a lever which will power this first piston. The piston has a redstone block. You'll push that down onto the next piston, powering that, and so on down the chain. So let's see that in action. and the final redstone block will power the lamp. Okay, so that's pretty straightforward. There's not a great deal to say about it, except I suspect actually there might be some issues with quasi-connectivity on Java, because there's something strange on Java about powering air blocks above pistons. If that's the case, you could probably just offset one piston here and the next one at this level, one here, and next one at this level as you go across. So that should solve that problem if it is an issue. Do feel free to let me know in the comments. So one thing you will notice about this one is it's stateful again. So we're back to stateful systems, which is great for me, but it's quite slow and it's quite noisy because a lot of pistons going off there. So I think we can probably do better, and we can do better by using slime blocks. So you probably know slime blocks stick to themselves and other things, and that means I can use one piston to push up to 12 blocks. So these slime blocks will all come down as a column. The redstone at the bottom is the 12th block attached to that piston. So it'll push that down, exactly the same principle as here, onto the next piston, and the next column will set off. So let's see that in action. And you can see already that is a lot faster than my previous system. And all of these work independently, of course. But what I've had to do is offset my pistons. And the reason I have to offset them is because slime sticks to itself. So if it was another column of slime down the middle here, they will stick to each other and get completely stuck. And you might go, yeah, well, egg fur, why not use honey in the middle? And I could do that, but actually at the bottom, I still have an issue because, actually, let me turn this middle one off to show you. If this was a honey column coming straight down the middle of these two slime columns, at the bottom here would be the redstone block, and that would be next to this slime block. It gets stuck, and the whole thing would break down. So if I was going to do that, I would need to find a different way of transmitting the power without using these redstone blocks. And funnily enough, this next one does exactly that. So just a quick demo. Again, it's the same speed as the previous one, it's pretty fast. And it does use alternating honey and slime. So let's see how I've done the mid station here. So when this column comes down, this honey block will sit in front of this comparator. The comparator powers the honey block. The honey block powers the redstone dust here, which powers this piston, and it pushes on down. So that's the way I've done the mid station. You may be wondering, how come if you're powering this redstone, it's not powering all of these pistons? What I've done is I've used a furnace, and it's got a single item in it. And a container with a single item powers a comparator to a power level of 1. That's enough to power this block, it's enough to power this redstone, but it's not enough for it to jump across to the next one. So that means that I can power the right piston that's in line with the block that's come down without interfering with the others. Down at the bottom, I've got these repeaters, they're always powered. So again, when my column comes down, it completes the circuit across between these repeaters, and I can light up my lamps, or whatever my system is down here. This could of course be some redstone dust with maybe just one lever or a torch or something like that. It doesn't really matter. It's up to you, depends how many you've got. So those are my 3 piston-based systems. So this is one that's maybe the most interesting. It's one that certainly I find the most interesting. It's based on daylight detectors, which are these spotty things down here. And let's have a quick example of how that works. Pull the lever, it turns the light on below, and these all work independently. The way that's happening is when I pull a lever, it extends a piston with a solid block on it. That solid block sits above the daylight detector, change the amount of light it gets, and that causes the lamps to light up. So one thing to note is these two at the back have to go that way. If they were coming from this side, the blocks would interfere with this first row of daylight detectors and before they got to these ones. So I need to put some clear glass in here. That doesn't impact the daylight at all, with some redstone on top of it, and that powers these levers, then come the other way and push a block just over this second line of daylight detectors. So I think it's probably worth us spending a little bit of time talking about daylight detectors, because they're something that maybe, if you're like me, you haven't used that much. I don't think the wiki explains them particularly well, so apologies if you're involved in writing an article. um, but there are two modes for daylight detector. One is the daylight detection mode, no big surprise there. That's this sort of yellowy color. But there's also an inverted daylight detection mode, which is this more sort of blue nighttime color. Um, the daylight detector mode just basically looks at how much light is coming down from the sun. It applies some calculations to that, and it gives an output power based on that. So at the moment in my world it's noon, the sun's directly overhead, and this daylight detector is pushing out a power of 15. This goes up to 16. You never get power 16, so just show that's the end. But power 15 at noon. At different times of day, you get different powers. Sunset 7, night, sunrise 2, and at midnight 0. So let's have a look at a couple of those. If I set the time to sunrise, for example,
Set the time to 1559000.
I get a power of 2 out of this. And if I set it to midnight, oops, I can type time set midnight,
Set the time to 1578000.
then this goes out completely. Okay, put it back to noon for now.
Set the time to 159000.
This one works differently. It's not just the opposite of this. What this one does is it takes the light level and it does subtraction of 15 minus the light level that's arriving at this detector, and that's the amount of power it outputs. So whilst this one is on some kind of strange curve, which is linked to the time of day and the weather and the light level, this one is more specifically exactly the light level that arrives here, taken away from 15. So at the moment, because it's noon, the light level all the way down in a big column from the sun is 15 on here. 15 minus 15 is 0, so this is off. Okay. At midnight, set the time to midnight.
Set the time to 160200.
Um, Interestingly, you might think the light level would be 0, but actually moonlight has a light level of 4. That's landing on here. 15 minus 4 is 11, and therefore I've got 11 lights lit up, and that's my midnight figure. So that's interesting. Even at the darkest of night, this doesn't go up to 15. The only way to get it to go up to 15 is in fully dark, underground, no skylight conditions. But during the day, this will be 0, so noon through to sunset. In fact, daytime in the morning after sunrise through to sunset, this will be 0. So one of the interesting things that I could do with this is if I put two of these next to each other, then they will both be they'll both be outputting the same level of power. Okay, so at the moment that power will be 11, and I can put this comparator into subtraction mode, and then it's doing 11 power from here, 11 power from here, 11 minus 11 is 0, so nothing coming out of here at all. And that is true at any time of the day or night.
Set the time to 161400.
So at noon, the time here is, the light level is 15. The light level here is 15. 15 minus 15 is 0. And then the comparator takes 0 from here and 0 from there. And obviously the output is 0 minus 0, also 0. Okay. Now, once I'm doing this, this one on the right, which goes into the side of the comparator, is acting as a control. So as long as it's got skylight coming down onto it, anytime I change the light level hitting this one, like that, then they're going to give me a different output. And this one is going to be a little bit darker, and so it's going to give me a stronger output. Okay, and therefore this one is actually got the column of light coming from the sun. It's at 15. This one you might think could be more blocked, but actually light travels sideways as well. So it comes down to here, light level 15. As soon as it starts traveling sideways, it starts losing power. So over here, one block to the side, it loses one light's power, comes down to 14. And therefore, this guy is doing 15 minus 14 is 1. This is doing 15 minus 15 is 0. The comparator does 1 minus 0 is 1. And actually, it doesn't matter where this sits, the answer is always the same. There's a difference of 1. And it doesn't matter what the weather is,
Changing to rain and thunder.
and it doesn't matter what the time is.
Set the time to 162000.
The answer will always be 1, because the light level is always whatever this one is getting, move to the side, so it loses 1 level of power, and therefore the output from the inverse detector goes up by 1. Okay, so let's put that all back to how it was.
Set the time.
Oops. All right, I was starting to get wet then. So hopefully that explains the mechanic that we're using. One thing to note is that this will not work if you're underground. So if these guys don't have access to the sky, then it will not work. And you'll have to come up with a different system, or open up access to the sky from both of them. All right, so let's look at the real one over here. This is my daylight detector. This is my control, and actually this control is acting as a control for both sides. So this is my second daylight detector, all set to inverse mode. Okay, so on the second row below, it's the same. So I've had to offset that obviously so it can see the sky. But I've got a middle one which is acting as a control for the two on the outside, comparators in subtraction mode. Okay, that comparator then powers this block. It'll only ever be a power of 1 maximum, but that's enough to power this dust, which powers this repeater, which turns the light on. And these ones behind have got a comparator powering a repeater, and then I can just run dust up to here to power the light. So hopefully that kind of makes sense. I put these red blocks here to show that you will not need another daylight sensor in this position. If you want to carry this on out to the side, remember that this is my active one, then this one, then this one, then this one. So my next one needs to be here, and then I'll have my control and my sensor, and up here I'll have my sensor, my control, and my sensor. Okay. So it's not quite 1 wide tileable, it's sort of 1.5 wide tileable, but it doesn't really matter because up at the top, my switches, my levers here can all be next to each other, 1 wide and tileable. So I don't care, it does what I need it to do. So what I'll probably do is I will create a build video for this. It's not very complicated. It's actually really simple. And the great thing is, of course, it doesn't matter how high up you go or how low down this is. You don't need anything in between apart from a hole. So, it's pretty cheap and it's just as fast regardless of how distant you want to go. So if you're doing really big distances, this could well be the answer for you. All right, so that's the daylight sensor downwards transmission circuit. Right, this is the last one for the time being. This is an item-based system. It's maybe the Cinderella of the bunch, although I'm not convinced that she's going to turn into a princess anytime soon. Although if you've got ways of, making her do that, then I am very willing to hear your ideas in the comments below. Okay, so an item-based system, these are talked about a lot on, various forums and stuff. I've seen them around. I guess they must have their uses. For me, I don't think it's a great system. But the way it works, I've got a lever. It'll light up this repeater that's seen by the observer, which sends a pulse into this dropper, and it'll drop an item. The item falls down a hole in the middle of this glass, lands in this hopper, gets pushed into this dropper, which is facing downwards, and at the moment it just sits there. So what happens next is this comparator lights up because it's seen an item in the dropper. That powers a piston. The piston pushes a redstone, which powers this piston, which pushes this observer against this observer. And when two observers start kissing, they get really excited and they start pulsing at the back. So they will hard power this. Well, this observer will hard power this dropper, soft power these two, and all of the items in those will just flow through, get pushed out of here into the water stream. I've got a soul sand block to make a bubble column. You don't necessarily need that because items do float anyway. So they'll pop back up here, go across here into that hopper and back into my dropper. So that way I recycle all the items. There are other ways of doing it. You could just come and manually, put some more items in once they're used up. You could maybe feed a farm over a hopper going into that dropper, and that would keep it topped up as well. So different ways of doing it. I wanted to recycle because I'm a recycling kind of guy. All right. Let's see this in action. So I pull the lever, drops down, and you can see the pistons working and the item coming back up. So let's see that again. Okay, so that looks pretty straightforward. Why don't I like it then? I don't like it because actually when I've done some testing, I found it really hard to find a way to make it either accurate or stateful, even when you really slow it down. So that's my issue with it. If this is a doorbell for your, secret underground lair, and all you want to do is, ring a bell or light up some lights when someone pulls on the lever, then it's probably great. If you want to understand exactly what's happening down below, I would say not so great. So if you're still with me after about half an hour, thank you very much indeed. I've really enjoyed making this video. I hope you've enjoyed watching it. And if you learned something, that's even better. If you did like it, please let me know by leaving me a like. Also, leave me any comments, anything you want to say. If you think there's stuff I could do better, if there's other things you'd like me to talk about, then let me know in the comments below. And thank you very much again for watching.